Here we are on page 2 of integration. On page 2, we're going to do something that we know the answer to, but it's still slightly more challenging than the triangle we did in the first one. Okay, we're going to calculate the area of a quarter circle. Okay, you would know how to do that. Actually, they did it right here. If the radius is 2, then the area of this quarter circle is exactly pi. Okay. We're going to use upper rectangles and lower rectangles to make estimates and find that it is between two numbers. Okay. Okay, so first we're going to cut our quarter circle into how many sections? Into 20 sections. So it would be a whole bunch of sections. Okay. What is the width of each one of these sections? It's going to be width of 0.1, right? Because if I take 2 and divide it by 20, I would get 0.1. So the first interval would be 0 to 0.1, the second interval would be 0.1 to 0.2, etc. The last interval would be 1.9 to 2.0, right? Let's do upper rectangles first. So this is a little bit tricky because in this case, do you notice that this function descends instead of ascends? So each one of the rectangles would actually be using the leftmost position at the beginning. So like if I cut this into a couple strips, notice that if I did upper rectangles, it would use the left x coordinate to calculate its height, right? And before, since we had functions that increased, we were using the right edge. So when we're doing upper rectangles, we would use the left edge number. Okay, so the first rectangle here, it would be width 0.1, right? Because it would be 2 divided by 20. And actually the width of all these rectangles would always be 0.1. Okay, no matter which one of these intervals it is. The height is going to change, right? So in the first rectangle case, we're going to use the left edge to calculate the upper rectangle because that's the tallest edge. So we're going to put 0 into our formula, and it would be square root of 4 minus 0 squared, and that would be the height that we would use for the first rectangle. Okay, and then for the second rectangle, instead of 0, we would be using 0.1 because it would be this second left edge here, 0.1. So we would put square root of 4 minus 0.1 squared. And then the next one would be square root of 4 minus 0.2 squared, right? And then the last one would be 0.1 times, and we would use the left edge again, so it would be square root of 4 minus 1.9 squared, right? Okay. And if you calculate each one of these, there would be a lot of work, but you could do it by hand. But I'm going to show you how to use the sigma function on the calculator, the summation. If we're going to do lower rectangles, the only difference is now we're just going to use the right edge of each one of these rectangles, because if we're going to do lower rectangles, what we want is the lowest possible estimate of the height. And so we would use these blue rectangles instead of the black rectangles. So the width is always going to be 0.1 like we used in upper rectangles, but the height, instead of using the left edge, we're going to use the right edge. So for this one, we're going to use 4 minus 0.1 squared. And for the next one, we're going to use square root of 4 minus 0.2 squared. And then the last one would be 0.1 times square root of 4 minus 2 squared, right? So do you see that we've created a pattern here, and the only thing that changes is this second number inside the square root sign? So we could rewrite this as a little program in the calculator using the sigma function. We could write sigma k equals, for this one we're going to count basically from 0 to 19, right? If we count from 0 to 19 and we multiply it by 0.1, it'll give us these numbers 0, 0.1 squared, 0.2 squared, etc. So first we're going to multiply the left number, which is always 0.1, and then after that we're going to multiply by square root of 4 minus, and then we're going to put 0.1 times k squared. And then remember that we got extra parentheses here because the calculator needs the extra parentheses. For lower rectangles, it would look very similar, except since we're going from 0.1 to 2.0, what we would do is we would count from 1 to 20, and then we would put these numbers in instead. Okay, so the formula, notice it looks exactly the same. The only thing different is, since we're going from 0.1 to 2.0, we're going to use k equals 1 to 20 instead of k equals 0 to 19. Again, this part of it is not, super important that you understand or enjoy this part, because it's kind of like programming, and some people love programming, some people are okay at it, and some people hate it. So if you are hating this part, then good, you've discovered that you should not be a computer programmer. Okay, so it's always good to discover what you hate almost as much as discovering what you love. Okay, so in here, this is my red parentheses, so I'm going to put extra parentheses for the black part. I'm going to put 0.1, close parentheses, open parentheses, and then I'm going to put square root, which is here, blue, square root, 4 minus, and then I'm going to put parentheses, 0.1 k, close parentheses, squared. Okay. And then I need to put one more set of parentheses because this parentheses already here is the red parentheses. I need a black parentheses. And the answer is 3.23, basically. 3.23. Okay, now that is an upper rectangle's estimate, so it's slightly bigger than the real answer. Now what I'm going to do is, since I have the exact same internal formula, all I need to do is change the outside from 1 through 20 instead of 0 through 19. I'm just going to, copy it over. And this hit enter. And my estimate for lower rectangles is 3.02. What is the correct answer again? The exact answer, it turns out it's pi, which is 3.14159. Notice that when we did upper rectangles and lower rectangles, we got numbers that surrounded 3.14. We got a number that's below 3.14, which is 3.02. It's the lower rectangle's estimate, and the upper rectangle's estimate is slightly above 3.14. So sounds reasonable. Okay, let's go through this reading section here. We have a drawing of a curve and an area under the curve. This is a little bit different than what we did before, because instead of starting with 0, we're starting with a non-zero value, which is A, and we're ending with the value of B. A and B are defining the left and the right edge of the red area. So A is the area under the curve between the left boundary x equals a and the right boundary x equals b. Write the definite integral expression to find this area. So it turns out that the way this looks in terms of calculus is, we draw an integral symbol, we put the value a at the bottom, we put the value of b at the top, so the left edge goes here at the bottom and the right edge goes here at the top, a little bit counterintuitive. And then inside we put the name of the function f of x, or we write down the function itself in terms of x. And last of all, we kind of put a period on it by putting dx here. We'll talk more about what that means later, but we just end the integral expression with dx. Okay, so this expression will give you the answer to this red area here, as long as the function is above the x-axis, which in this case it is. Okay? We'll talk more about that in a second. What letter of the alphabet is the integral symbol related to? So this integral symbol that we drew at the beginning, what letter of the alphabet is that related to? It turns out it's related to the letter S. And did you notice that to do these estimates, we were using the Greek letter sigma? The capital sigma, which looks like this, sigma is actually the Greek version of S. So why do we use sigma for summations? Well, because summation starts with S. Why do we use a scripted S for integrals? Because an integral is like a summation. We're adding up the blocks underneath the curve, So that's why it kind of looks like a long S. All right. Number 1A, sketch the graph of y equals square root of x from x equals 0 to 1 and shade the area described by this expression here. So we just learned what this means. Now we're actually going to use it. So if I have the square root function, you may not remember, but the square root function is a sideways parabola. So if I was going to graph it from 0 to 1, it would look kind of like this. And if I was to find the area underneath, I would say, oh, okay, so that would be this area here. So I'm shading the area that goes from 0 to 1, and the function is the square root function, which I have drawn here. Okay? All right, now we're going to use lower and upper rectangles to find this area. And we're going to divide the area into 10 sections, 10 vertical sections, 10 rectangles. Notice that this is an increasing function. So if it's an increasing function, then that means when we do upper rectangles, we're going to use the right. We're going to use the right boundary of the interval. And when we do lower, we're going to use the left boundary. Okay, so just like we did before, we're just going to do width times length. The width of this estimate is always going to be 0.1 because we took the interval from 0 to 1 and we divided it into 10 sections. So it's going to be 0.1 always for the width. The height is going to be the function value when we plug in the right value. So if we plug in 0.1, it would be square root of 0.1. That would be our height. And the second height would be square root of 0.2. And the third height would be square root of 0.3. And of course, the last height would be square root of 1.0. Okay, and we just add all those up. And for the lower rectangles, it would be very similar. The only difference is instead of using the left boundary, we're going to use the right boundaries. So the first one's actually going to be square root of 0. And the next one is going to be square root of 0.1. And the next one is going to be square root of 0.2, and so on. Okay? And the last one is going to be the 0.9, so it'd be square root of 0.9. Okay, so I'm going to write down the expressions that you would use to program on this calculator, but on an exam, you could just add these numbers up. The exam wouldn't have 10 sections. It would probably only have 3 or 5 sections, something that you could do quickly, even if you weren't, that good with the calculator. So for this one, since we're counting from 0.1 to 1.0, I'm going to go from 1 through 10. For this one, since we're going from 0 to 9, I'm going to go from 0 to 9. Of course, 1 through 10 or 0 through 9, notice I have 10 rectangles for each because n equals 10. And the first number is always 0.1, and the second number is going to be square root of 0.1 times k. This one's going to be the exact same formula. The only difference is the k values are going to range from 0 to 9 instead of 1 through 5. Okay, so let's use the calculator to do these. We'll do math, press up, and then we're going to put alpha k, and then we're going to put 1 through 10. And then these parentheses are here are the red parentheses. I want to put black parentheses. 0.1 times square root 0.1 k. And then I need to put my final parentheses. Enter. Oops, I think that it didn't like the fact that I have put way too many parentheses. Okay, I had too many parentheses. Okay, 0.711. Okay, so this is going to be 0.711. Now I'm going to do the same thing for lower rectangles. All I need to do is modify my k counter to go from 1 through, instead of 1 through 10, I'm going to go 0 through 9. 0 to 9. 0.611. Okay, so looks like the correct answer would be somewhere between 0.611 and 0.711.